So, welcome to the first class of this course on network security. So, what we do in this week is we look at some of the concepts for network security and also we look at some of the primitives of cryptography so that when we go to the main part of the course where we talk about different network protocols and the security vulnerabilities and attacks and the countermeasures, you should be able to more understand what we are talking. So that way, this week we'll use the time to talk about some of the basic primitives and concepts related to network security and also cryptography. So if you look at in general the IT security problem that we are talking here, there is a lot of software out there, and many times you also know it has lots of bugs, and only by testing with the users, many times the company discover the bugs and try to fix it, and in that process they introduce more bugs. So that way, this cycle is forever going on before they replace the product with a new product in the market. Again, the story repeats. So all of you quite familiar with that part. And of late, what we are also seeing is the social engineering. It seems it is more effective than other ways of getting things done or the things getting broken. And as you seen in this snapshot that you see it on the right hand side, of late, even I see myself getting so many spam messages over my mobile connection. So now I'm not talking about the WhatsApp messages and other things. I think nowadays I think WhatsApp has taken good care of these things. But I see with my mobile connection, which is from like companies like BSNL and other things. So there's a lot of spam messages. They don't look like spam. I think if you read the message, they're quite tempting, and also when you start engaging with these people, you also start getting the money initially, but only in the long run you see that it is a big scam. So the internet has made the social engineering very easy with these multi-level marketing strategies. It has become quite easy to deceive the people and exploit confidential information and do some fishy things with the kind of information that they gather. And also, if you look at in terms of money that is involved here, there are multiple things here, and there is a marketplace. That means there's like a Flipkart and Amazon kind of marketplace for vulnerabilities. That means in this marketplace you can buy tools using which you can exploit these vulnerabilities and attack somebody else's systems. And also there's a marketplace where you can buy software using which you can inject these malware viruses and trojan horses in somebody else's machines so that you can use those machines to launch denial of service or other kind of attacks. So there the charge is like per installation maybe 20 cents or 30 cents or something you have to pay to the company which is providing this as a service. Here the idea here is how to compromise the devices, because many times the security measures or the security protocol that are in place, they try to detect when there is a huge amount of traffic, the kind of sessions coming out of one location and one IP address. To circumvent that particular thing, to make sure that you are invisible in spite of having these intrusion detection systems and whatnot in the internet. So many times these attackers and these denial of service people, they are trying to use these machines which are nothing but the machines that all of us own, which are compromised. Many times you don't even know that they are compromised. The idea here is use your machine to launch some attack on something else. So your machine is more acting like a kind of a relay kind of thing where you are not really losing anything here except that your ID is kind of being exploited for launching the attack. And also, there are lots of methods here to profit from these machines, owned machines or these compromised machines. And you might have heard about there's a lot of bounties on finding vulnerabilities and even fixing them. There's like many IT companies have these kind of schemes where you can get money by just finding the vulnerabilities, if not fixing them. And what you see here is very confusing and very vast cyberspace. That means when I say cyberspace, the kind of companies that are involved here in the cybersecurity landscape. You can see, I know you may not be able to read this illustration very carefully, but the point is there are tons and tons of companies which are trying to sell varieties of products. But in spite of all that, you still see that internet is broken, and every other day you hear lots of attack being launched and exploiting something and some data breaches and whatnot. That it is quite complex and quite confusing, even for experienced people to deal with. And before I go further, as I mentioned in the beginning of this class, let's look at some of the basic concepts related to the security, cyber security, and network security in today's class, so that all of us should have a common understanding of these keywords and the common abbreviation that we use in this course. So what you see here is the English meaning of what mean by security, which is nothing but state of being free from danger or threat. I think all of us understand that quite well. And also you can see here how the term cybersecurity is defined. It is defined as the state of being protected against the criminal or unauthorized use of electronic data or the measures taken to achieve this. So that way, cybersecurity encompasses many things out here. So it is a very broad term. These are what you see in English dictionary. But let's look at more specific definitions that are coming out of IETF, that is Internet Engineering Task Force. In one of the RFC, that is 4949, so they have defined security as this way. Security is defined as a system condition that results from the establishment and maintenance of measures to protect the system. And also it is defined as a system condition in which system resources are free from unauthorized access and from unauthorized or accidental change, destruction, or loss. And in terms of the measure that one can take to protect your computer system, and in one of the test book, Mr. Parker has mentioned that one can employ 6 different functions to make your systems are secure. One of them is deterrence, other one is avoidance, prevention, detection, recovery, and correction. These are not mutually exclusive, but the organizations and the individual users can think about using these different functions to make sure that your system is protected. And you can look at the URL that is kept at the bottom of this slide if you want to really know about other keywords that are defined in this particular IETF draft. So these are the things that you need to keep in mind when you are talking about cyber security and internet security. And in terms of cyber security, there is also one other broad definition that is given by ITUT, that is the telecommunication sector of International Telecommunication Union. So they have defined X.1205 as the document which talks about what is cyber security and the recommendations for the cyber security for the organizations. So if you look at here, so it defines cybersecurity as the collection of tools, policies, security concepts, security safeguards, guidelines, risk management approaches, actions, training, best practices, assurance, and technologies to protect the cyber environment and organization and user assets. So that way it is also a very broad definition and it includes varieties of things. When you look at the word cyber environment, it also includes the physical space in which you house your devices. When you're talking about servers and workstations which are kept in data centers and offices, even the protection of the room with the physical locks also comes broadly under the cybersecurity paradigm. And here, when you're talking about the assets and organization assets and user assets, they include varieties of devices and varieties of applications and data set that one having here. Okay. Cybersecurity here strives to ensure the attainment and maintenance of the security properties of the organization and users' assets against relevant security risks in the cyber environment. Okay. Let's come to the main topics. And if you look at here, it is well accepted in the community that whenever you are talking about providing cyber security or information security, you should able to provide three guarantees or three assurances. It is also called as a CIA Trinity, which basically stands for confidentiality, integrity, and availability. Where integrity many times also includes authenticity and non-repudiation. So I will explain these words in more clear manner in the following slides. But whenever we are talking about information security or cyber security, we are talking about building systems with these objectives in mind. And nowadays we also talk about the privacy in addition to these three main objectives when you are building cyber systems or cyber physical systems. And if you look at in terms of the various elements that are there as part of any cyber security system, and you can think of having security services at the application layer in your protocol stack, which basically keep your software and the devices free from various threats. And also it includes information security, where we are talking about the protecting integrity and privacy of the data, both while it is in transit and also when it is stored in computers or when it is there in the main memory. And in this course, we'll talk about mostly on network security, where we are concerned about how you can secure your computer networks from attackers by controlling the network connections using various security protocols and mechanisms. So that's what we'll talk about. But if you broadly look at cybersecurity, it is very vast. It looks at application security, information security, network security. It also talks about even disaster recovery and business continuity plan, where the disaster recovery basically tells about how a given organization recovers from a cyber attacks that causes either data loss or affects its various operations. Basically, each organization should have disaster recovery plan, using which whenever something goes wrong, you can simply apply that particular protocol to bring back your operations to the normal state. That is about the disaster recovery, how we can recover from the attacks. Here that we are assuming that there is a possibility for you to recover from the attacks, and sometimes that is not true. There is also another related word here that is called BCP, that is business continuity plan, which basically tells how organization falls back while trying to operate without certain resources. So during these cyber attacks, maybe a certain part of your system or the resources may be unusable. In that case, how you can still continue operating your business with limited services and support while you are trying to recover the rest of the things. So that way, in the context of cyber security, each organization should have this disaster recovery and business continuity plan. And also it involves operational security. It talks about including procedures for handling and protecting the data assets. So while you are dealing with the data, so we need to see how we can handle and protect the data from unauthorized access and unauthorized modifications. And last but not the least, you can also see that end user education is also equally important as part of the broad cyber security framework. And unfortunately, if you look at many times, people are the quite weak link into entire cyber security paradigm and the framework. As I was mentioning, with the clever social engineering attacks, the end users are the one actually, many times these are the inside users by clicking some attractive links or some links that try to lure you towards certain products and services, you end up compromising your own device and also letting other devices and other nodes in your computer network are getting compromised and attacked by the external entities. So end user education is also equally important, but it is very challenging. We also see in our campus educating users to follow the good cyber security policies and digital hygiene is always very challenging. But there is no alternative to that. We have to keep educating the users by conducting awareness programs and whatnot. And when it comes to the network security, we use these friends and enemies, Alice, Bob, and Trudy. I think some of you have already heard about these names. These are well known in cryptography field and also in network security field. Where what you see here is on the left hand side, we have Alice. She wants to securely communicate with Bob over a wired or wireless channel, and assume that there is some intruder or the attacker, like here it is Trudy. She is interested to understand what is happening between Alice and Bob. Either she wants to simply eavesdrop onto the communication, or she wants to delete the communication messages exchanged between them, or add new messages or the modify these messages. So depending on what Trudy is trying to do here, it is going to affect three objectives that I talked about: the confidentiality, integrity, and the availability. I will talk about what are these three main keywords in information security, how they can be compromised when you have attackers in between the communication between sender and receiver in the following slides. But you have to remember that. So this is the typical paradigm in which we talk about network security. And if you look at in the real world, who might be these Bob and Alice? Again, there could be, it could be literally anything that you can think of in cyberspace. This could be web browsers and web server, which wants to communicate with each other when you are doing web browsing or when you are doing these online purchases and whatnot. Even in the case of banking, also we use the client server system. Even this could be the DNS client and the DNS server, where you want to resolve the domain name with an IP address. So in that case also, this could be, one could be Alice and other could be Bob, and attacker could be the one that is trying to provide you the some spoofed IP address or some redirecting to the some other website which is trying to mimic the website that you are really interested in. And also there could be the routers which are trying to exchange the entries for the routing table and the shortest routes and whatnot in the internet. Similarly, these could be the remote access when you're trying to use the VPN or the SSH to connect to campus or enterprise network. Yeah, your client and the remote server, they form Alice and Bob. Even when you're talking about the WhatsApp and when you use email and online chat, anytime we have at least two parties, they want to communicate over each other over a internet system, which comprises of many other servers and many other routers and switches in between the sender and the receiver, depending on what kind of application that you are talking about here for the communication. And what these bad people can do here, so they can do a lot, as I was mentioning in the previous illustration. At the very least, they can do eavesdropping, where one can silently listen to what is happening on the channel. So it is like a passive attack where you are interested to know what is happening between sender and receiver. You would like to use that information to do something else, but as of now, you are not going to disturb between what these two are talking secretly. And other one is you may want to insert messages into the ongoing communication, as I was mentioning, where you are trying to add new messages so that the receiver will think that that message is indeed sent by the sender. And other one is impersonation, where you actually are spoofing the sender or the receiver of the communication so that other party doesn't know that you are talking with some impersonator, not the uh, person who is claiming to be. So very popular technique like a MAC address spoofing and IP address spoofing all can be used for this kind of impersonation. Hijacking, where you are taking over the ongoing communication by removing the sender and receiver and inserting yourself in the communication. So where what you do it, you kind of hijacked and you are kind of neutralized one of the parties in the ongoing communication during the middle of their communication. And afterwards other parties think that he or she is still talking with the original person that is on other side, but in fact you are talking with somebody else who is also impersonating somebody else. And also you might have heard a lot about denial of service, where you want to make system and the resources unavailable for genuine or the legitimate usage for their users, where what you do is you try to overload the system resources by sending varieties of denial of service attacks like IP flooding or SYN flooding, and we can also use pink flooding and whatnot. There are lots of such denial of service attack one can launch, which basically make the server not available for the users to use. So that way the attackers can do many things, uh, as simple as passive attack to very sophisticated distributed denial of service attack, as you seen in this list here. And if you look at the security trinity, that is the CIA, the confidentiality, integrity, and the availability. So these are very important in the context of cyber security and information security. Let's spend some time looking at what these three keywords mean and how they are related with each other and what kind of guarantees or assurances they provide you for making your system secure. The first one in this trinity is the confidentiality. It is basically a property that your data is not disclosed to system entities unless they have been authorized to know the entity. So when you're using the word system entity, it basically means anything. It could be the computer, or it could be the user, or it could be the attacker, or whatnot. As long as they have the authorization to access the data, they can use it, but otherwise the data should not be made available to the users if they don't have the authorization to access the data. So that is the meaning of confidentiality. And many times what happens is when these unauthorized users start accessing this confidential data, it leads to a breach of confidentiality. So that way somebody else who is not supposed to access the information try to start accessing the information. If you look at examples like in the real world, there are many high profile data breaches in companies like Yahoo and credit card companies, where the credentials of the users are available in the dark web or in internet for anybody to start seeing it. So the username and password and other personal information are supposed to be, including the credit card information. These are like a confidential and private information that yourself and the organization who is you are interacting with should have access to it and authorized to access it. But since that same data is made available for anybody to start looking at, here we are talking about the breach of the confidentiality, especially when the data is made available for parties which are not supposed to use the or access the data. And when you are talking about the network security context here, we say that only the sender and the receiver of the communication should understand what is the content of the packet that you are sending. The way that is achieved in network security is the sender does encryption on the message and the receiver does the decryption. So you can use that DES and AES and many other encryption algorithms for encrypting and decrypting the messages. So using these encryption mechanisms, you can achieve the confidentiality of the data when you are trying to send the data over networks. When you are really concerned about also the quantity or even the destination of the communication, we say that it is called traffic confidentiality. That means you are not only wants to hide the message that you are trying to convey to the other party, you also want to hide what is the size of the message and whom you are sending the message. That means even you wanted to conceal the metadata related to your communication. If you look at in the context of ongoing privacy uproar on WhatsApp. So WhatsApp is talking, saying that your messages are end-to-end encrypted. So WhatsApp is saying that there is absolute confidentiality. Only the sender and receiver only can understand what you are trying to send and receive. But WhatsApp also in the same agreement, it kind of told you that it is gathering a lots of metadata about what time you are accessing that app and with whom you are talking and to what amount of the time you are talking and what is the sizes of the messages that you are exchanging, whether it's a message or whether it is a video or whatnot. There's a lot of metadata that WhatsApp is gathering, and many people are concerned that even with metadata and even with the encrypted messages, there is a lot one can infer. For example, take an example of your location history is made available by Google to some third party agency. By just looking at where you all traveled in the last 1 month or 1 year, one can able to figure it out what kind of business that you do or what kind of activities you are trying to do. And by getting even the location data of other users in the same localities, it can actually indirectly figure it out. Most likely, who are the ones you are trying to meet and what is the kind of activities that you are involved. So that way, even the metadata is also very, very vital. And in the world of this confidentiality and the encryption and other thing that you do, metadata is also equally important. I think that kind of explains why many people are upset about the modified WhatsApp privacy policy. So anybody having any queries on this part? What is the meaning of confidentiality and what happens when you don't have the confidentiality, what can be done to achieve confidentiality? So any queries or any comments?
So good afternoon, sir.
Yeah, please go ahead.
Hello.
Yeah, Prashant,
Sir,
yeah.
Yeah, this traffic confidentiality, can you give some more information about it, sir? I didn't get. That means if the destination IP address or something like that is also encrypted, then then how does the message passes through other routers? That means the core network.
No, okay, I think that's a valid question, Prashant. See, there are multiple ways you can achieve this confidentiality of the destination address. You might have heard about this, the TAR protocol, the onion routing protocol. Basically, what it does is when you wanted to talk with a certain receiver, what you do is basically you do the IP in IP. That means you want to, let's say you want to talk with your friend. So the source address is your IP address and the destination address is your friend's IP address. Then you compose the original IP packet, but you don't send the IP packet as it is. What you actually do is you put this IP packet inside another packet where your computer identifies some relay node, which are basically the other devices which are part of the Tor network, where the sender IP address is your IP address and the next hop IP address is the IP address of the computer, which is part of the Tor network. So like that, by adding like it is more like an onion. So you see, right, in onion we have many layers, and you can assume that at the core of the onion is what the original IP packet. On top of that, you do IP in IP, IP in IP, IP in IP. So depending on how many relay nodes that are there between sender and receiver. So by doing that, what you can achieve is any node that is there in the path from the sender to receiver, it cannot get the complete information about whom you are talking with. For example, when you are sending it to your friend only come to know that you want to talk with somebody else, but your friend also doesn't know what you want to talk, I mean, with whom you are trying to talk with that, because this packet is already encrypted with not encrypted, I mean of course, encryption is always happens. Not only do the encryption, you also do the IP in IP, where you put another hub node IP address here. So like that, we can try to hide. See again, even though I'm using the word concealing from whom? So many times you do want to do this concealment from the ISPs, and you also want to do the concealment from the law enforcement agencies. And by doing this traffic confidentiality, it becomes very challenging for these ISPs, because it only gives you the partial information. Only by stitching together all these from different ISPs, then you can only figure it out who is talking with who. So you come to know more about this when you talk about the onion routing protocol. And for that matter, the simplest example for this could be the VPN. So you are using VPN to connect to IIT Hyderabad campus network, right, Prashant?
Yes, sir. Yes, sir.
So even in the case of VPN, what is happening is your original IP packets are kept inside another IP packet. I mean, let's say you wanted to browse internet, but you already connected to the campus VPN, and you wanted to still check your email and all. So then what happens? First, all the packet come to our IIT Hyderabad campus. From there, they get relayed to there. So that way, we can use the VPN, and we can use the this Tor routing protocol to conceal the destination IP addresses. And for doing the concealment of the message size and all, sometimes what people do is they also add this arbitrary the padding bits, so that one may not able to figure it out whether it is like for example, it is like a ICMP packet, or whether it is like a TCP SYN packet, or it is like a DNS query packet. Because if you look at all these things have standard packet sizes. By adding some padding bits randomly, you can try to make sure that whoever is trying to decipher what is happening between sender and receiver, you can able to make their job very harder when you try to do something randomly by adding these padding bits.
Okay, sir.
So we'll come back and discuss again. We'll discuss these issues as part of the various topics that we cover in this course. But at the high level, yeah, you want to magically conceal from ISPs, or from your computer, or from your parents, or from somebody else. Yeah, again. So yeah, depending on from whom you want to conceal, we have to come up with a different kind of strategies here.
Yes, sir. Thank you.
Okay, and the related term here is the privacy. Privacy is not the same as confidentiality. And if you look at what is the definition of privacy as per IETF RFC 4949, it basically says that privacy assures individuals control or influence what information related to them may be collected and stored, and by whom and to whom that information may be disclosed. In other words, the end user should have absolute control over what information of them is getting collected, and whether you want to share that information with anybody or not, you should have the absolute rights. Even in way back in 1948 itself, United Nations declared privacy as one of the human rights. Even long before even internet was born. But even in the current internet world, thanks to all these smartphone revolution, the privacy has becoming very, very difficult for anybody to assure and provide you that easily. And it is becoming very, very difficult to get private communication happening in this digital world. For example, if you look at when you fill any online form, for example, you are applying for higher studies, where you apply by filling an online form. By filling an online form where you specify your name and your parents' details, your home address, and your also your mobile number, So that way you are actually providing, even including your date of birth and whatnot. So actually all these are very, very private information and the confidential information. By filling this form, you are kind of trusting the receiver of this online form to safeguard your confidential information. But you'll be surprised to know there are hundreds of companies that are there whose business is to gather the information that is collected from these online forms. By paying some fee, they can sell your private information to law enforcement agencies or even for other purposes. So that way, there are lots of companies whose job is to compile and consolidate the private informations of the individual users. So that way, nowadays you might have heard about European Union has brought up new privacy laws. Basically, these laws basically says that whoever is asking any personal information from anybody has to declare for what purposes they are going to use that data and how long they are going to store their data, in what form they are going to store data. That way, you have the absolute right over whether you wanted to accept that kind of privacy policy or not. That is one way. Many times your private information is known to other people. And also, if you look at in the current digital age, all our lives are easily monitored by companies and governments and even by unknown entities. Whether you agree or not, all of us carry a small tracking device with all the time. But we don't call that tracking device, but we call them as smartphones. And the companies that made these smartphones, I mean the operating systems that are installed in these devices, with the help of the GPS and other kind of location-based radios that are available in that, they can actually track you much more than what your parents or your relatives know about yourself. So that way, security and privacy have become major issues even now, thanks to the current cyber security landscape that you see in nowadays. And the second one in security trinity is the integrity. Here we are talking about two different terms. One is called data integrity and other one is the system integrity. What data integrity means that your data has not been changed, destroyed, or lost in an unauthorized or accidental manner. Okay, so this could be applicable whether data is in transit or whether data is in storage. So the data should not be tampered with as simple as that. That's what the data integrity means. And in the context of network security, you want to make sure that whatever the data that is transmitted by the sender is not altered or tampered in between by the malicious users like a Trudy that you have seen in the previous example, without the detection by the receiver. Even if somebody is trying to tamper it, you should have protocols and algorithm in place which can help you to detect such a tampering. So many times you use these message authentication codes and secure hash algorithms for achieving the data integrity. And another term that you also hear a lot is called system integrity. Here it is the quality that a system performs its intended function in an unimpaired manner, free from deliberate or inadvertent unauthorized manipulation. So here we are not just talking about the data level, we are talking about the system level. Whether your system is compromised or not, whether system has been infected with malware or some spyware which is trying to do something different or more than what you are intended the system to do. So that is the meaning of system integrity. Integrity also means you should be ensuring the information non-repudiation and also authenticity of the information. When you say authenticity, basically we are talking about you have to give guarantees that you are really talking to whom you think you are talking. So when you are trying to connect with let's say you want to check your Gmail or whether you want to log into your Flipkart account, The web server wants to verify that whether it is indeed you who are trying to log in and make a transaction or access the data. So many times we use authentication mechanisms like user ID and passwords for authentication of the clients, and for the authentication of the servers we use digital certificates. So using the combination of digital certificates and user ID and passwords, we try to achieve the two-way authentication. But it's not all the ways it is a two-way authentication. For example, when you try to, for example, you want to do a Google search, assume that you are not logging into your Gmail account. So in that case, you are connected to Google search server over a secure connection using HTTPS. It gives the confidentiality of the information that you are sending between yourself and the Google server. And because Google service is having a digital certificate, your browser can validate whether the reply is indeed coming from the Google search engine or not. But Google has no knowledge whether it is talking with you or somebody else, because there is no user authentication here, because you are not logged into your Gmail or whatever the credentials that are given by Google. But if you log into your Gmail, then we can also say that yes, you are also being authenticated by the Google search engine, where your credentials are getting validated before you start doing this secure search in the Google. That way we have these mechanisms in place for achieving authentication. So in the next class, I will talk about more on what are the digital certificate, how they can be used to do the validation and whatnot. So we'll talk about that in the following classes. And another related term here is non-repudiation. Basically, it kind of assured that someone cannot deny something. So repudiate here means denying something. Basically, here it ensures that the sender of the information is provided with the proof of delivery, and the recipient is provided with the proof of the sender's identity. So neither can later deny having processed the information. So it is also quite important when you do any transactions online. So you want to make sure that, for example, let's say you have sent an email, a message to your friend or a document to your friend over email. How you know that indeed the message was delivered to your friend? So nowadays, you see some people started using email trackers. These are also called red receipts, using which the sender can be alerted as soon as the message was delivered and read by the receiver. So that kind of ensures that yes, the message was indeed delivered and read by the receiver. But if the receiver wanted to know whether the message was indeed sent from the sender, the kind of technique that we use are called digital signatures. By signing the document with the private key of the sender, the receiver can actually verify whether the message has indeed been sent by the sender or not. So that way we can achieve both the client and both sender and receiver side assurances, and kind of ensuring that they don't back off from whatever the information that they have sent. That is called non-repudiation. So non-repudiation, authentication, and integrity all are very related. So they all comes under one of the three objectives as part of the cyber and information security. So the last one is the availability. So basically here we are talking about.
Sir, could you give an example of system integrity one?
So I was mentioning, right? See, data integrity means you are just interested in knowing. Let's say, maybe take an example. You have a computer and you have lots of file in your computer. Data integrity basically means that all the files that are created in your computer by you are not tampered by somebody else by having a backdoor entry into your computer. That is called data integrity. So what is the meaning of system integrity is, for example, a good example is, let's say you have a CCTV camera. So when you bought the CCTV camera, the objective is you wanted to install that in your premises so that you can monitor what is happening around your house. So That is the intended operation of the CCTV camera. But what you don't want this particular camera to do is if some attacker or some hacker kind of gets a backdoor entry into this CCTV camera and start sending a stream of the data that is being captured into a third party location. So basically we say that the system is compromised, and that is one case. And other related case is when your CCTV camera is capturing the data, it is possible that one can actually tamper with the data. That means maybe a part of the CCTV footage can be deleted, or part of CCTV footage can be modified so that they can able to make sure that you are not aware of what is really happening in your neighborhood. So that is system integrity means system should be doing what it is supposed to be doing. It is not altered for purposes which was not for which it was not designed. Does that make sense?
Yes, sir.
Okay, so the third one I'm talking about is the availability. Here you want to make sure that your system or some resources of your system are always available for genuine usage for the end users. It should not be the case that these resources are overhelped so that the intended users don't use them. Okay. So in other words, a system is available if it provides services according to the system design whenever users request them. Like for example, somebody wants to access IIT Hyderabad web server. So we want to make sure that whenever some user want to visit, our web server should respond them by providing the homepage. That if there is any attack that makes our web server unavailable, then the genuine user who are trying to connect to our web server don't get any response from the web server. So it is basically a very obvious requirement for information and computer security. For example, if you turn off your computer, then also you have both confidentiality and integrity of your system, but it is going to seriously hurt the availability. So that way we want all the three objectives, including the privacy that I was mentioning in the previous slides. And the DDoS attacks or the DOS attacks, they are direct assaults on the availability of the system. So as I was mentioning, there is a marketplace using which you can launch DOS attack on a certain organization or on a certain service by paying some money. You don't have to do it yourself. So again, I'm not saying that you should be doing it, but the things have gone that bad in the current internet. And there are a couple of more definitions that one should be keeping in mind here. So one of them is called that one of them is the vulnerability. I think you use this word very commonly. So basically it means a flaw in either hardware or software or service or firmware, whatever it is, that can be exploited, causing a negative impact on the confidentiality, integrity, or availability of the system or the system components. So try to understand, here we are talking about a flaw in the system or a component of the system that can be exploited, which is going to seriously affect one of the three objectives of information or the cybersecurity. So these vulnerabilities allow attackers to run unauthorized code, access system information, and steal, modify, or destroy data. So ideally you want to make your system not having any vulnerabilities. But unfortunately, there are lots and lots of vulnerabilities. There are vulnerabilities at the design or the specification of the system. When the design was not done properly, then by the time the system is made available for the usage, these vulnerabilities could be exploited by the attackers. And sometimes the design may be very good. There are no issues in the specification of the system, but the poor implementation because as you see, for the same protocol or the same algorithm, because of the heterogeneity of the operating systems and hardware that are out there, there are many implementations that one has to make. So if there is any flaw or weakness in the implementation, even though design or specification is good, so they could lead to some vulnerabilities. And the third one is in the operation and the maintenance. So here, even the implementation was good, at the configuration stage or even at the maintenance stage, if you have not followed the best practices, they also could lead to some vulnerabilities that could be exploited by the attackers. Having said that, not all the vulnerabilities result in attacks, and not all the attacks are successful and lead to a lot of inconvenience to the system owners. It all depends on the degree of vulnerabilities, the strength of the attacks, and the effectiveness of any countermeasures that organization has kept in place. So depending on all these factors, the impact could be quite different. Another related word term for vulnerability is the exposure. Here the exposure is an error in code or a configuration issue that gives an attacker indirect access to the system or network for information gathering or hiding their activities. So try to understand the difference between vulnerabilities and exposure. Here in the case of exposure, we are talking about giving indirect access to the system so that one can gather the information. As an example that I was telling you earlier, if somebody able to get unauthorized access into the system and get to know the confidential information about the credit card information, that leads to the data breach. So that it is a kind of an exposure that we are talking about here. But in the case of vulnerabilities, the attackers can actually hijack the system and they can run the code, and they can also delete or modify the data that you have kept in the day. So that way both vulnerabilities and exposures are related, but they are not the same. And in this slide, what you see is the top 15 products that are currently out there. They are ranked in terms of the number of vulnerabilities that have been discovered so far. These are all known vulnerabilities. That means either the developers of these systems or the third-party users have reported that these systems or these applications are having these vulnerabilities. These are all called known vulnerabilities, but there are also unknown or the zero-day vulnerabilities, which are not known as of now to anybody, or even if they are known, they have not made them public. That means they are not kept in the CVE database that is out there. So interestingly, if you look at this slide, it is quite surprising to see that at the top, if you look at the top 5, I think all the top 5 products that you see that are having the highest number of vulnerabilities are all based on Unix. If you look at the Mac OS, that also has a small flavor of the Unix. That way, Android is also based on Linux. So that way you can see that surprisingly, Windows 10, once upon a time, it used to be having lots of vulnerabilities and whatnot. So it is there in top 13. But the Linux has come to the forefront. So then came, I think, Windows and other kind of applications and the operating systems. And if you look at this slide, it shows about the vulnerabilities that are there in Android. And the left-hand side illustration shows the vulnerabilities by year. So as you can see that these are varying across the years. And the right-hand side, it is showing what kind of vulnerabilities are there. So these are, is it SQL injection, or it is a buffer overflow, or whether it's a denial of service, whatnot. So that one can understand a lot of information by looking at these vulnerabilities disclosures that are made by the developers of these particular products or the software systems. Let me show you something here for all of you. So this is the worldwide database of the vulnerabilities and exposures. It is called CVE database. Basically, it is maintained by MITRE, which is a non-profit organization. It gets all these CVE records from US National Vulnerability Database and also from the makers of the products and the services. They give this unique number. Basically it talks about which year and what is the vulnerabilities ID, so that it becomes easy for somebody to understand what is the vulnerabilities, how to fix them and whatnot. And also you can see here there is a CVE numbering authority, so it shows that of late Sophos, WP Scan and Samsung are also have been added as CVE numbering authority. That means whenever Samsung found any vulnerabilities in any of their mobile phones, they can directly start assigning the numbering to their vulnerabilities, and they can be automatically pushed into this worldwide database of the vulnerabilities. That's what it basically means. And yeah, I was showing, right? Okay, this is the CVE database. You see a nice illustration here. As I was mentioning, these are the top 50 products by the number of vulnerabilities that have been out there. And if I click on one of them, let's say I click on Android here, it shows now whatever I was showing earlier. So by the type of the vulnerabilities and the number of vulnerabilities categorized over the years, all that information that you can see. And as you see, the like denial of service, code execution, buffer overflow. So you can see all these are known vulnerabilities, and over the years they have been fixed or they have been deprecated and the new systems have been deployed. If I come back and if I go back to one of them, so let me show you an example. Let me show this one. So this is the ID for the vulnerabilities. Basically, it was discovered in 2019. So you see a small description. It is basically there is some issue with the heap buffer overflow in Android version 10. Okay. And also there is something called the CVSS score. It got the score of 7.5. So basically it is still orange, not the red here. And it also tells you this vulnerabilities has affected any of the basic objective of the information security. It tells you, for example, you can see here whether it has any impact on the confidentiality of the data. It says that yeah, the impact on the confidentiality is partial. Similarly to you see, is there any impact on the integrity, availability, access, complexity, authentication, and gained access? So like that, you can understand what kind of vulnerability is this. Or if I look at the first one, yeah. So it is saying that there is no effect on the confidentiality of the data. There is no impact to the confidentiality of the system. And authentication not required. Authentication is not required to exploit the attack. So the attacker need not to get authenticated to your system to launch this particular attack by exploiting these particular vulnerabilities. Okay, so like that you can see that and it is impacting Samsung mobile phones, some other phones, and it was also released in 2019. So go to this particular website, and if you are really interested to know, and as I was mentioning, these are the scores 9 to 10, and if you look at here, this is the distribution of the vulnerabilities by the scores. You can see there are very high number of vulnerabilities with orange and red, which is quite bad. And what I also wanted to show here to all of you is this is the RFC, not this one, RFC, where is it? 4949, which basically talks about what are all the standard keywords in the internet security domain defined by IETF. You can see all of them here. You can see in the section 4, you can see the meaning of each and every keyword that you see here. So there are lots of keywords, but you don't have to worry, but try to at least get a high level understanding of what all these keywords are and how they are different from each other, so that you can able to, yeah, as they are also defined, Alice and Bob also has keywords here. Okay, so let me continue. And few more definitions are related to threat and attack. Basically, threat is nothing but an attacker or an adversary that is motivated and capable of exploiting a vulnerabilities in the system by launching attacks. So there are different kind of enemies that are out there with the different abilities, and you cannot design a secure system unless you know whom your enemy is. First, you should know who are all your enemies and what are their capabilities. Then you can think about how you can guard your system against these attacks. But many times it is very challenging to estimate who are all these adversaries. And if you look at the meaning of attack, attack is nothing but an intentional act by which an entity attempts to evade security services and violate the security policy of the system. So the adversaries or the attackers launch these attacks by exploiting the vulnerabilities that are there in the system. And you can see there are two kinds of attacks: passive and active attacks. Passive attacks basically means attacker is interested to gather information without affecting the system resources, where attacker simply doing the eavesdropping or monitoring of the network traffic in the case of network security. Since the attacker is not doing anything that is detectable, it is very difficult to detect passive attacks. The only way one can prevent these passive attacks is by applying this cryptographic mechanism like encryption. Encryption helps you to guard against these passive attacks to a greater extent. And the second category of the attacks are active attacks. They try to alter the system resources or affect the system operation, like the denial of service attacks, man in the middle attacks. They all comes under active attacks. And these attacks, because one is actively doing something on network or the system that is out there, it is possible to detect these kind of attacks if you have intelligent intrusion detection and prevention systems in your network. But preventing them is not that easy. As I was mentioning you, there are thousands and thousands of vulnerabilities, and it is becoming very, very challenge to prevent the attacks, where the attackers have exploited these some vulnerabilities. And as I was mentioning, there are also instances where these vulnerabilities were not known to the developers or to the security researchers, but they were known to these attackers or the hackers, where they're trying to use them for their own purposes. That way, it is very difficult to prevent these active attacks. The main goal is how you can detect them. Once you detect them, how you can recover them, or how you can isolate those systems so that you can able to come back to the normalcy in a quick manner in your system. And if you look at attackers, they can be classified into several types. Like if you look at the individual level, we have insider attackers, outsiders. The trusted and the privileged insiders are also there nowadays. Even that also becoming another big issue. And also there could be at the group level, it could be ad hoc group or it could be an established group. And attackers could be at the organization level. So where the organization could be your competitor, which is trying to launch attacks on your product, or it could be your supplier, or it could be your own partner, or it could be your customer who is trying to attack your system, or it could be the state or state sponsored actor. So nowadays we are hearing about these attacks where the government agencies are involved in launching cyber attacks on other governments' IT infrastructure or the cyber infrastructure. And also attackers have varied capabilities in terms of the time, money, training, and access to the systems and resources. And the motivation or intent could be different, like curiosity, fame, money, and nowadays it is becoming a national interest that is causing a big trouble for many people. And whenever you are talking about this network security or the cyber security, one important thing first we need to ask here is what is the threat model? So if you don't know what is the threat model, there is no point in trying to figure it out how to defend against the attacks. Okay, first one has to define the threat model. If there is no consensus on what is the problem that we are trying to tackle, then we cannot provide a new solution for the problem, right? So as a simple example, if you look at you have certain assets, it's like a toy example, like if you have some TV, smartphone, and jewelry at your home, these are the assets. In the case of network security, these are like your IT assets, like your firewall, your router, and your servers, and other equipment that you have in your campus or enterprise that you wanted to protect. And trust boundary is also very important. And the assumption here is when I say trust boundary, the entities that are inside the trust boundary are the ones they have the authorized access to these assets. Like in this toy example, it is given that your roommate and your spouse, if you have, they are the one you trust. That means they can use these assets, or they have free access to these assets. But what is your attack scenario here, or what are the attackers? You can assume, or you may want to assume, it could be your roommate or your thief. And depending whether you say your attacker is roommate, you need to have one kind of a solution in place. But if you say that it is only the thief, you may have to have one kind of solution that you have to design for safeguarding your physical assets in this example. Same thing goes in the case of even cyber security as well. So there's something called risk assessment, which basically tells you that you have to protect your IT resources from these attackers and hackers. And this risk assessment or analysis involves various steps. The first one is understanding your system requirements. When you are building any IT system, for what purpose that you are building this system, and in the system what are your various assets, and what are the attackers that are possible to which are interested to attack your system. Then you have to establish what are the security requirement for your information system that you are trying to build. Then you have to evaluate how good is your system that you have designed. Then you have to identify the threats, and you have to classify the risks that are out there. And once you know what are the risks that are out there, you may want to address these identified risks. So sometimes the risk could be, the probability of that particular thing happening could be very, very low, but the cost of you fixing that particular risk could be quite humongous. In that case, it is up to the organization to figure it out whether to leave with the risk as it is, or to do something about the risk, or whether you want to pass that risk to some third party. For example, you may want to buy, let's say, cyber insurance, so that if something happens fishy, or when it really, if that particular risk manifests, then the insurance company will bear the cost of that particular thing. So it is very similar to what you do in a real life when you do many different activities, but in the cyber world also these things are becoming more and more important, and it is a wake-up call for everyone to start seriously looking at the risk assessment of the IT infrastructure. So again, I'm saying this even for our own campus as well. And if you look at in terms of the attacks, we can broadly classify the attacks into three broad categories. One of them are eavesdropping or monitoring attacks, which I was briefly describing earlier. The second category is the man-in-the-middle attacks. So there are varieties of man-in-the-middle, and also there are varieties of denial of service and even the distributed denial of service attacks. And these eavesdropping attacks basically affect the confidentiality of the data that is exchanged. Many times you use the encryption, and in the case of wireless, you try to hide the signal by changing your carrier frequency. And the second category is the man in the middle. I will describe more about these kind of attacks when we are talking about the web security using HTTPS and TLS, where this attacker or the 2D, how that can try to intercept or modify or alter the communication that is happening between the sender and receiver. Here it is going to affect the integrity of the thing. So typical solutions are the two-way authentication and the digital signatures, using which we can able to provide the integrity of the data. But many times what is happening is, even though we have lots of security protocols like TLS and whatnot, there are many vulnerabilities that have been discovered in the protocols which are designed to fix these security gaps. So that is the sad story of the cybersecurity landscape. And denial of service, again, we'll also talk about this. Yeah, so these can be launched at the various layers in the protocol stack, all the way from the application layer, transport layer, IP layer, MAC layer, and even the physical layer. So one can launch varieties of the denial of service, and the purpose could be either to make the system unavailable or make the system less responsive to the genuine users or the legitimate users. And these denial of service attacks nowadays are becoming more like a distributed denial of service by exploiting these compromised machines with the help of this malware and other Trojan horses and whatnot. So that way, these traffic which are emanating from different users spread globally looks more like a genuine traffic to the website owners, but objective here is wasting the system resources from the genuine users. So detecting whether it is a genuine access or that it is like a DOS denial of service kind of access becomes quite challenging here. Okay, and for the next class, so I want all of you to look at this seminal paper written by Ken Thompson, who wrote Unix and many other things on reflections on trusting trust. So he talks about in this particular article, what to trust and what not to trust. Whether you want to trust the program, or whether you want to trust the computer, or whether you want to trust the firmware, or whether you want to trust the compiler. So go through this article, and also I will share you one other video given by David Clark, one of the leaders in internet design. So what he says about the history of internet and why, what kind of security they thought about when internet was designed, why QoS is not there even today in internet. It's a very interesting historical lecture with lots of insights on the design of internet that all of us use today, and why we are still stuck with the same internet that was designed or kind of been evolving for the last 50 years. So go through these articles by this weekend, and we'll meet again on this Thursday. I think I have 5 more minutes, and if there are any queries that I will take. Any queries from anybody?
Sir, in that example of CCTV, so you told like if some footage is being deleted, it comes under system integrity.
So what you are saying is that is coming more like data integrity. That's what you mean?
Yes, that's my doubt.
Okay, see again, that's what I meant, right? See, there are two things we are talking about. When you're talking about data integrity, data at rest, and the data at transit. That is one thing. But what I was trying to tell you out there, where the hacker or the attacker injecting a malicious or a malware which basically tells you or basically access your confidential video footage and sending it to some other location. Yes, when he is modifying, yes, it comes more like a data integrity. But when he is sending to some through some particular third-party cloud server or cloud service, then it becomes more like a system integrity because your system is doing something it was not supposed to be doing it because somebody has compromised the system, right?
Yes, sir. Understood.